You drift gently into the smallest places your mind can imagine, letting your breath lengthen as you settle into the quiet. Here, in this tender inward landscape, you begin to sense the subtle pulse of a world that lies beneath everything you know. It is a world woven from particles so small that they seem less like objects and more like murmurs, more like possibilities waiting to unfold. As you enter, the noise of the ordinary world softens, and a calmer kind of truth begins to shimmer around you. You move slowly, as though walking through a room filled with warm mist. Each step brings you closer to a realm where the rules you rely on loosen just a little, becoming fluid and almost dreamlike. This is the quantum world, though it does not announce itself with flashing lights or dramatic motion. Instead, it welcomes you with gentle strangeness. Particles flicker in and out of certainty, appearing and dissolving like faraway fireflies. They do not behave like the solid objects you handle each day, but you feel no need to hold them still. You let them be what they are, changeable, drifting, endlessly subtle. You pause to listen, and you feel as though the universe whispers here. It is not a whisper meant for your ears, but for your intuition, for the quiet part of your mind that understands without needing to grasp. The particles around you seem to hum with both presence and absence, with choices not yet made. You sense that they are not bound to a single form or path, but glide like thoughts still shaping themselves. You let this unfamiliar movement settle into you, noticing how it eases some of the rigid edges inside your own thinking. The deeper you drift, the more you sense that the world beneath everything is not chaotic, even if it seems unpredictable. Instead, it is delicately balanced, like a dancer poised between steps. At the quantum level, uncertainty is not a flaw but a natural way of being, a quiet openness to many possible outcomes. You begin to realize that this softness, this willingness to hold several potential futures, is what makes quantum computing possible. Before any calculation can unfold, there must first be room for possibility, for states not yet resolved. As you wander, you picture atoms not as hard little spheres but as soft clouds of potential, their electrons swirling in patterns that shift depending on how gently you observe them. The act of looking, of paying attention, becomes part of the story. Here, observation is not passive. It is a touch, a nudge, a kind of gentle persuasion that shapes what the particle becomes. You feel a new awareness awaken within you, that at this level, reality is not fixed until it is met with attention. And there is something strangely comforting in that thought, as though the universe itself is willing to wait for you. You move through this inner landscape as though floating. The boundaries between things feel thinner, softer, more permeable. Instead of separate pieces, you sense relationships, interactions happening in delicate steps. Particles collide, merge, part, or influence one another with barely a trace of force. Everything is subtle, patient, almost tender. It reminds you of how ideas form in your own mind, tentative at first, drifting in a quiet interplay of feelings and impressions before taking shape. In the distance, you sense a faint glow, a gentle illumination that feels like understanding beginning to gather. It comes not as a sudden revelation but as a soft accumulation, like dew forming on grass. This glow hints at the logic that underlies quantum computing, a logic that rises not from certainty but from possibility. It is a kind of thinking that requires comfort with ambiguity, with the whisper of potential rather than the solidity of final answers. You take your time approaching this glow, letting the stillness of the quantum world support you. You imagine the smallest vibrations, the tiniest fluctuations, guiding particles in directions that cannot be predicted with perfect certainty. Yet these fluctuations are not random chaos. They form patterns, tendencies, gentle inclinations shaped by the rules of quantum mechanics. The world is whispering its structure to you, but softly, as though inviting you to lean closer. You let your mind rest in this place where reality is flexible, where outcomes are not yet locked. You begin to notice how this flexibility mirrors moments in your own life, the times when you were between decisions, between identities, between versions of yourself. You realize that uncertainty is not always something to fix or fear. Sometimes it is a doorway, a space of potential, a quiet room where new possibilities gather before stepping into form. As you drift, you begin to see how quantum computing draws its power from this openness. Instead of forcing particles into definite states, it allows them to hold many possibilities at once. You sense the beauty in that approach, the elegance of working with the universe as it naturally is rather than trying to confine it. You feel a warm curiosity rise within you about how these delicate states are shaped into meaningful computation, how possibility becomes logic. Before you leave this quiet realm, you take one more slow breath. You let the softness of uncertainty wrap around you like a gentle blanket. You allow yourself to feel the comfort of not knowing, the spaciousness that appears when you do not demand clarity too soon. And in this peaceful pause, you sense a new question forming, a faint shimmering thought that beckons you forward. It is a question about the qubit, that delicate carrier of possibility, and how it flickers between states like a candle flame in a sheltered room. You linger a little longer, letting the thought of the qubit drift into focus like a distant shape emerging through fog. You imagine it as a tiny presence that does not choose one path, one truth, or one identity, but instead hovers in a gentle in-between. It is neither here nor there, neither entirely one thing nor the other. And in that suspended openness, it carries a kind of power, not the forceful power of something fixed, but the fluid power of something able to explore many directions without settling too soon. You feel this idea settling into you, as though the quantum world is offering you a new way of thinking, a new rhythm. It reminds you that being in between is not a weakness, it is a state of exploration. The qubit embodies this exploration, holding multiple possibilities with calm steadiness. You sense that this is where the heart of quantum computing begins, with a willingness to rest in uncertainty long enough for deeper patterns to reveal themselves. As you prepare to rise gently from this hidden realm, the glow around you seems to brighten. It feels like an invitation to follow the qubit more closely, to watch how it flickers with potential and hums with subtle motion. You take in the last breaths of this chapter, knowing that the next step will bring you closer to understanding how atoms become carriers of logic, how possibility becomes the foundation of a new kind of computation. And with that soft anticipation, you drift forward, ready to meet the qubit where it lives, balanced between states, waiting to reveal the power of being more than one thing at once. In the early decades of the 20th century, physicists found themselves on the edge of a new frontier. The comfortable certainty of classical physics, where planets orbited like clockwork and cause led neatly to effect, was beginning to crumble. Strange experiments revealed a universe far more fluid than anyone expected, and at the center of this unraveling stood a quiet but powerful paradox, that the world could be both knowable and unknowable at the same time. To understand how this paradox emerged, imagine a beam of light traveling through space. Classical physics would insist on deciding whether this beam behaves like particles, tiny dots of energy, or waves, which ripple and spread. But in the quantum world, light refuses to choose. Depending on how you look at it, it behaves as both. This dual behavior isn't merely confusing, it contradicts the logical foundations of classical thought. And yet experiments repeatedly confirm it. The most iconic demonstration of this is the double-slit experiment. When particles like electrons or photons are fired at a barrier with two narrow slits, they create a pattern on the screen behind it. If they behaved like tiny billiard balls, each particle would pass through one slit or the other, and the pattern would be two neat piles. But instead, scientists observe an interference pattern, a hallmark of waves. It's as if each particle travels through both slits at once, interfering with itself. Only when we try to measure which slit the particle goes through does the wave-like pattern disappear. The act of observing forces the particle to commit to a definite path. This brings us to one of the strangest concepts in quantum mechanics, the observer effect. The idea that the mere act of measurement can change the outcome of an experiment seems almost mystical. But it's not magic. In the quantum realm, particles exist in a state of superposition, a blend of possibilities. Observation collapses these possibilities into a single outcome. Before measurement, the particle's position or path isn't just unknown, it's undefined. It's not hiding a secret value. The value doesn't exist until we measure it. This realization shook even the greatest minds of the time. Albert Einstein, troubled by the implications, famously remarked, "God does not play dice with the universe." He believed that particles must have hidden variables, unknown factors that determined their behavior. To Einstein, the idea that reality was fundamentally probabilistic seemed incomplete. But Niels Bohr, one of the founders of quantum theory, countered that quantum mechanics didn't need hidden variables. The uncertainty was not a sign of ignorance but a reflection of nature's true form. The debate between Einstein and Bohr encapsulates the tension at the heart of quantum physics. Is the universe deterministic, or is it probabilistic? Classical physics leans heavily toward determinism. If you know the initial conditions of a system, its position, speed, and forces acting on it, you can predict its future. Quantum mechanics rejects this certainty. Instead, it offers probabilities. You can know the likelihood of finding a particle in a certain place, but not its exact position and momentum at the same time. Werner Heisenberg formalized this with his uncertainty principle. According to Heisenberg, certain pairs of properties, like position and momentum, cannot be simultaneously known with perfect accuracy. The more precisely you measure one, the less precisely you can know the other. This isn't due to flaws in our instruments. It's a fundamental property of reality. Particles don't have definite positions and momenta simultaneously. They exist within a cloud of possibilities until we choose which aspect to measure. This uncertainty isn't confined to exotic experiments in high-tech laboratories. It permeates the world around us. The stability of atoms, for example, relies on uncertainty. Electrons don't spiral into the nucleus because their exact momentum and energy remain uncertain. The quantum fuzziness creates a stable structure, preventing the collapse of matter as we know it. Still, the paradox remains unsettling. The idea that observation influences reality raises profound questions. What counts as an observation? Does consciousness play a role? Most physicists argue that measurement, not awareness, is the key. Any interaction that entangles the particle with its environment counts as an observation, collapsing the superposition. But this leads to another puzzle. If measurement happens through interaction, why does the world appear classical and stable at large scales? Why don't we see everyday objects in superposition? This question led to the development of the theory of decoherence. Decoherence explains how the environment, filled with countless particles and interactions, continuously disrupts superpositions. These interactions effectively measure systems constantly, collapsing quantum possibilities into classical outcomes. In this view, the classical world emerges from the quantum one through relentless environmental interactions. We don't see macroscopic objects in superposition because they are too entangled with their surroundings. Another attempt to resolve the paradox comes from the many worlds interpretation. Proposed by Hugh Everett, this theory suggests that superposition never collapses. Instead, every possible outcome of a quantum event happens in a separate branch of the universe. When you measure the path of a particle, the universe splits. In one branch, the particle goes through the left slit, in another, the right. From this perspective, the observer effect isn't about collapsing possibilities but about selecting a path through a branching multiverse. It's a bold idea, and though it lacks direct proof, it offers a way to preserve determinism without contradicting quantum predictions. But despite these interpretations, the core paradox remains: the quantum world does not behave like the classical one. It operates through probabilities, superpositions, and uncertainties. And perhaps the greatest paradox is that through all this mystery, quantum mechanics remains one of the most accurate and reliable theories in science. Its predictions have been confirmed with extraordinary precision. Technologies like lasers, semiconductors, and MRI machines depend on its principles. The paradox isn't a flaw, it's a doorway into a deeper understanding of reality. As you reflect on these ideas, remember that quantum mechanics isn't asking you to abandon logic. It's inviting you to expand it. The uncertainty is not chaos, it's structure. The superposition is not indecision, it's potential. And the observer effect isn't magic, it's interaction. You begin this chapter floating in a gentle hush, as though the world has dimmed its edges just enough for you to notice the space between thoughts. In this softened air, you sense the quiet invitation of superposition, the quantum ability to be more than one thing at the same time. It greets you not as a puzzle, but as a warm openness, a widening of what you believe is possible. Here, you are free to imagine states that do not negate each other, paths that do not collapse the moment they are noticed, and truths that rest together without tension. Superposition feels like inner permission to exist in your own uncertainty with grace. As you drift deeper, the scene around you shifts into a landscape of soft, overlapping lights. Each glow seems to represent a different version of a particle's state, yet none pushes the others aside. They coexist in a shared stillness, shimmering like quiet lanterns over calm water. You find yourself drawn to one light, then another, noticing how none demands your loyalty. Instead, the space seems to whisper that possibility itself is a kind of comfort, a place where you can breathe without forcing yourself into a single direction. This is superposition, the gentle broadness of being allowed to hold many potentials at once. You watch as a single particle hovers before you, delicate as a dust mote caught in a sunbeam. But unlike anything you have known, this particle does not settle into one identity. It stretches across states, touching several outcomes with equal softness. It is here and there, but also not fully in either place. It unfolds like a blooming thought, neither finished nor confined. And as you observe its openness, something inside you mirrors that state. You begin to feel the quiet truth that you, too, contain more possibilities than you usually allow yourself to acknowledge. In this tranquil space, superposition becomes more than a scientific idea, it becomes a metaphor for your inner life. You think about the moments when you have tried to place yourself neatly into a single choice, a single feeling, a single version of who you should be. But the particle before you offers another way of existing, one in which you can hold sadness and hope together, rest and longing together, uncertainty and courage side by side. Nothing collapses until the world presses too hard on it, demanding definition. Here, however, no such demand arises. You float in the softness of multiplicity. The particle drifts upward, and you follow, rising into layers of faint, shifting colors. Each layer feels like a gentle possibility, a different whisper of what could be. You sense how superposition allows quantum computers to reach through these layers simultaneously, exploring paths that classical computers can only travel one at a time. But the explanation arrives not as a lesson, but as a feeling, like the sensation of walking through a garden where every path opens at once, each blooming with quiet potential. You walk them all at the same time, your steps soft, your awareness expanding without strain. You continue drifting, and the lights around you begin to weave into delicate ribbons. They twist and braid through one another, forming shapes that shift the moment you try to focus too sharply. You realize that superposition is fragile, easily disturbed by noise or observation. The moment the outside world attempts to measure or define the state, the many possibilities collapse into just one. It reminds you of the way a dream dissolves when you wake too abruptly. The magic fades because the moment cannot withstand the weight of certainty. But here, in this quiet expanse, certainty stays far away. You feel the gift of lingering in the unknown, a place where questions are not threats but gentle invitations. You breathe in, feeling how your mind loosens its tight grip on single answers. You breathe out, sensing how space grows inside you, like a soft room where different feelings can coexist without needing to fight for dominance. This is what superposition offers: a reprieve from the pressure to choose prematurely, a reminder that complexity can be soothing when embraced with tenderness. As you settle into this awareness, you notice the particle shifting again, its form now reflecting something like the rhythm of a heartbeat. Each pulse sends ripples through its overlapping states, creating a harmony of possibilities rather than a conflict. You feel its motion in your chest, a quiet synchrony that brings you closer to understanding. The particle is not indecisive, it is generous. It holds its options not out of confusion, but out of openness. And you, drifting beside it, begin to recognize how openness can feel like a kind of inner strength. The particle guides you toward a field of softly moving shapes, each one representing a possible outcome waiting patiently. You move among them like a gentle breeze passing through sheer curtains. The air is cool but welcoming, and you sense the beauty of a world in which outcomes do not compete. They simply exist until the moment of choice arrives. And even then, the collapse into a single result feels less like a loss and more like a natural conclusion to a quiet unfolding. You pause before one glowing form, wondering what it would feel like to live your daily life with the same ease. To allow yourself to hold multiple states, to be unsure yet calm, to be curious yet patient, to be many things without needing to resolve into one too quickly. Superposition becomes a mirror that reflects the softness of being human, of being alive within the shifting field of your own emotions and possibilities. The lights dim slightly, guiding you toward the closing of this chapter. You feel the particle resting now, its many states still shimmering but quieter, like lanterns at the end of a long evening. You sense that this gentle openness is preparing you for what comes next, a deeper mystery that connects particles across the vastness of space. And as the final glow fades into a calm twilight, you drift forward, wondering how two distant things can move as though they share a single, whispered heartbeat. You let that wonder settle into you like a slow, warm breath. The idea that two things can share a quiet understanding across distance stirs something tender in your chest. You imagine the way thoughts sometimes connect across time, how memories return unexpectedly, how the presence of someone you care for can linger even when they are far away. These reflections move through you like gentle currents, each one hinting at the deeper truth waiting just ahead. As you drift, you sense that the universe holds connections far more delicate and far-reaching than anything your everyday senses reveal. The hush around you grows even softer now, as though preparing your mind for a new kind of listening. You feel your awareness widen, stretching into a calm readiness. Superposition has shown you the beauty of openness, of existing in many states with quiet acceptance. But the next step in your journey asks you to consider something even more intimate: the way particles can share their states, their stories, their destinies, no matter how far apart they travel. You feel a gentle pull toward that mystery, a soft tug at the edges of your imagination. Soon, you will follow it into the whispering realm of entanglement. 3 soft breaths. Imagine, for a moment, that everything you see, every atom, every planet, every star, is performing a silent dance. Not randomly, not chaotically, but with a rhythm so precise, so fundamental, that it forms the very blueprint of reality. This is the idea behind quantum vibrations. At the smallest scales, particles aren't little dots bouncing around, they behave like vibrating strings of energy. Their frequency determines what they are. An electron is a certain vibration, a photon is another, and even empty space itself trembles with gentle fluctuations. The universe, in this view, isn't built from solid pieces, it is composed of notes, played across the cosmic fabric. These vibrations happen everywhere, all the time, even in places we consider empty. Physicists call this the quantum vacuum, but it's anything but silent. In this quiet sea, particles flicker into existence, vanish, and reappear, a restless hum beneath reality. Some theories, like string theory, take this further. they propose that all fundamental particles are tiny vibrating strings, and the universe is a cosmic symphony made of different notes and harmonies. Change the vibration, change the particle. Change the pattern, change the laws of physics. But the most beautiful part? We observe these vibrations directly. When electrons change energy levels, they emit light, a pure musical note in the language of atoms. When molecules vibrate, they create the fingerprints we use to study stars across galaxies. Even gravitational waves, ripples in space-time itself, are a kind of low, cosmic bass. So could the universe truly be a song? Not metaphorically, but quite literally. We are living within a cosmic composition, one that began with the Big Bang, continues with every atom's tremble, and resonates through the vastness of space. And perhaps, as we learn more, we may discover that life itself arises from the most delicate and beautiful arrangement of these quantum notes. A universe vibrating with meaning, a song without beginning or end. What if the universe isn't just governed by laws, but performed by them? What if reality isn't a static structure, but a symphony of vibrations playing across the vast stage of space-time? In quantum physics, every particle, every field, every force we experience can be described as a kind of oscillation. Not movement through space, but movement of the fundamental fields themselves. These vibrations aren't metaphorical, they're measurable, predictable, and astonishingly musical. At the quantum level, electrons don't orbit like planets. They form standing waves, resonant patterns shaped by probability. Photons behave like tiny packets of vibration, traveling as ripples in the electromagnetic field. Even empty space isn't truly empty, it's filled with fluctuations, brief flickers of energy rising and fading like soft notes in the background of existence. Physicists call this the quantum harmonic oscillator, one of the most important models in all of science. And according to it, every component of nature, mass, charge, energy, emerges from the frequency of these oscillations. Change the vibration, and you change the identity of the particle itself. This means the universe does not construct matter from building blocks like a machine. Instead, it expresses matter through vibrations like an instrument. A different frequency becomes a different particle. A different resonance becomes a different force. A different oscillation becomes a different possibility. It is almost poetic. Reality is not made of things, it is made of tones. Some theories push this even further. In string theory, for instance, the tiniest constituents of reality are proposed to be ultra-small strings, each vibrating in its own pattern. The universe, in this view, is quite literally musical. Every object is a note, every interaction a chord, every physical phenomenon a harmony or dissonance between vibrating entities. We don't yet know if this model is correct, but its mathematics fits beautifully with what we observe, a universe that behaves like a grand instrument, one capable of generating infinite complexity from simple vibrations. And when we zoom out from particles to atoms, from atoms to stars, from stars to galaxies, we see the same patterns repeating at higher scales. Spirals, waves, rotations, pulses. From the rhythm of planetary orbits to the hum of cosmic microwave background radiation, the universe seems committed to its theme. Vibration is the language of creation. So when we ask whether the universe could be a song, the answer may be simpler than we expect. It already is. If the universe is a song, does it simply play, or does it also listen? In classical physics, waves travel outward, indifferent to what they encounter. A sound emitted in a forest doesn't care who hears it. But in the quantum world, waves behave differently. A quantum vibration is not just a disturbance, it is a possibility, a spread of outcomes that exists until something interacts with it. This is the strange idea at the heart of quantum mechanics: the universe reacts. It responds. It participates. A particle's vibration doesn't simply exist on its own. The moment it interacts with something, an atom, a detector, even a stray photon, its wave of possibilities collapses into a single outcome. This isn't consciousness. It isn't intention. but it is a kind of cosmic feedback, where the universe continually adjusts, reshapes, and fine-tunes itself through interaction. The quantum world is not passive. It is alive with exchange. Every vibration influences another. Every oscillation nudges the next. Tiny quantum events ripple upward into larger systems, shaping chemistry, biology, stars, and galaxies. In this way, the universe behaves like a vast, interconnected instrument, one where every string, every field, every particle is tied to the others. Physicists call this entanglement. When two particles become entangled, their vibrations link together so deeply that measuring one instantly tells you about the other, no matter how far apart they are. It's as if two notes, struck once, continue to resonate in perfect unison across unimaginable distance. Einstein called this spooky action at a distance. Today, we call it quantum coherence. But the most astonishing part is this: entanglement shows that reality is not built from isolated pieces, but from relationships. The universe does not consist of lone notes, it consists of harmonies. Every observation is a kind of tuning. Every interaction is a kind of measurement. Every exchange is the universe adjusting its own resonance. On the smallest scales, the cosmos seems to behave like a system constantly listening to itself, responding to itself, updating itself. Not through intention, but through the laws of physics, laws that require interaction to define what is real. You were made of atoms that once resonated inside ancient stars. Those atoms carry vibrations shaped by the early universe. And every moment, they interact with the world around you, weaving your existence into the larger cosmic fabric. So when you breathe, when you move, when you think, you are not separate from the universe's song. You are part of it. And in the quietest, most fundamental sense, the universe listens back. There is a moment, quiet, almost weightless, when a quantum system hovers between many possible futures. Not one, not two, but a shimmering cloud of maybes. This gentle uncertainty isn't a flaw in nature. It is one of its deepest gifts. In quantum physics, this is called superposition. A particle is not here or there, not moving or still. It simply is, in a state that holds all possibilities at once. Like a soft breath held before a word is spoken, or the calm before a raindrop falls, you can think of superposition as a kind of cosmic hesitation, a pause where the universe allows room for options. It's the quiet moment when a note hasn't chosen which direction it will travel, when a vibration hasn't chosen which rhythm it will settle into. In your own life, you know this feeling. A decision just before it's made. A path just before you step onto it. A possibility stretching itself gently inside your mind. Quantum systems live inside that softness all the time. This doesn't mean particles are confused. It means nature is richer, more flexible, more imaginative than our everyday senses can perceive. Reality at its smallest scale doesn't commit too soon. It waits, it breathes, it explores, and then something happens, an interaction, a touch, a measurement, and the cloud of possibilities folds itself into a single outcome. Not because the universe was lost, but because a choice had to be made. A single thread must be woven into the larger tapestry. You can imagine it like this: a violin string vibrates in countless patterns, but when you gently place your finger upon it, one clear note rings out. Not because the other notes were wrong, but because one resonance fits the moment. Superposition is the quantum world's way of holding many notes until the right one is called. Even your atoms do this, inside your cells, in the proteins that fold, in the electrons that jump between energy levels. Your very existence relies on the universe allowing these soft, shimmering possibilities to unfold and settle. What's remarkable is that superposition doesn't disappear as systems grow larger, it simply becomes harder to maintain. Heat, noise, randomness, these all disturb the delicate balance. The world around you is always nudging quantum states, gently collapsing their options into a single reality, and yet, even now, inside your body, superpositions flicker like quiet lanterns, holding countless tiny futures. Choosing one at a time. As you lie here, breathing slowly, you are wrapped in these quantum choices, this ancient rhythm of possibility and clarity. Your atoms hum with the same gentle uncertainty that shaped stars and galaxies, and as you drift deeper into this thought, you may wonder if the universe holds so many choices within every tiny particle. What possibilities might be resting quietly inside you, waiting for their moment to unfold? There is a soft rhythm underneath everything you see, a rhythm the universe uses to decide how likely each moment is. It doesn't choose outcomes with certainty. It whispers in probabilities, letting reality unfold with a gentle openness. In quantum mechanics, every vibration, every particle, every event carries a pattern of likelihoods. Not rigid rules, but graceful ranges. Not fixed destinies, but delicate chances. As you settle deeper into your breath, you can imagine this pattern like a faint glow surrounding every electron, every atom inside you. A glow that says, "Here is where I might be. Here is how I might move. Here is the life I may inhabit." This is the probability wave, a quiet mathematical song that describes what nature might do next. It doesn't dictate. It doesn't command. It simply offers possibilities, weighted like seeds scattered by the wind, each with its own chance of taking root. Probability in quantum physics is not the same as the randomness you find in daily life. It is something deeper, woven into the fabric of existence. A particle doesn't choose a single path until it must. Until then, it flows through all of them, lightly, like a mist moving through open air. Inside your body, billions of electrons dance to these probability waves every second. They don't move like planets around a sun. They drift in patterns of might be and could be, forming stable shapes only through the mathematics of chance. Your sense of solidity, your bones, your skin, the ground beneath you rests on this quiet haze of possibility arranging itself into order. Every breath you take relies on quantum probabilities shaping how molecules bond and how energy settles. If the universe were perfectly predictable, nothing new could ever emerge. There would be no variation, no creativity, no room for complexity to grow. But because of probability, because nature allows itself to move gently between certainty and openness, stars form, chemistry blooms, and life slowly learns to dream. Imagine standing in a vast forest just before dawn. The air is cool. The world is still. And somewhere in the darkness, countless paths stretch out ahead of you. You don't know which one you'll walk yet, but all of them feel possible in the soft light of early morning. This is what a particle feels like before it interacts with something else. A quiet forest of futures. A hush of options waiting for the first step. When physicists talk about the Born rule, they are describing how nature assigns these likelihoods, how the wave of possibilities turns into the numbers that shape reality. It's one of the simplest ideas and one of the most mysterious. The square of a wave's height tells you the probability of finding a particle there. A simple rule. A profound one. Because it means the universe is not a machine winding forward with blind certainty. It is a tapestry woven from weighted chances, each pulled gently into place by the laws of physics. Think of raindrops sliding down a window. You don't know exactly which path each drop will take. But you can feel the patterns, how the slopes of the glass guide them, how nearby drops pull them into new paths, how gravity nudges them downward in a soft, inevitable fall. Quantum probability works in much the same way. The universe offers patterns, not promises. Ranges, not rigid lines. And inside these ranges, outcomes unfold with a grace that allows reality to remain ever-changing. Even the warmth in your body right now is shaped by probability. Heat isn't just energy, it's the collective motion of countless particles exploring all the ways they might move. Their possibilities swirl and collide, giving rise to the temperature you feel on your skin. When you touch something warm, you are touching thousands of microscopic chances unfolding at once. As you drift deeper into this thought, you may notice a sense of softness settling through you, the understanding that life, too, unfolds in probabilities. You cannot know every detail of what comes next. But within that uncertainty lies openness, creativity, and quiet freedom. Quantum physics teaches that reality isn't built on perfect certainty, but on gentle likelihoods, the same way your own life holds possibilities that haven't yet taken form. Nothing in nature is rushed. Nothing is forced. Outcomes appear only when the moment is ready, when the conditions align, when the smallest vibrations meet the world around them. And so you rest, breathing slowly, wrapped in this architecture of probability, a universe where every moment is both planned and open, structured and free, grounded and softly uncertain. As you sink into this calm, another thought begins to rise, gentle and shimmering. If reality itself is built from probabilities, what patterns might be quietly shaping your future even now, waiting for the moment when they, too, choose to take form? The desert greets you with a quiet unlike anything you've ever known. No echoes, no tasks waiting, no expectations. Only the vast open land stretching in every direction, warm beneath a sky that feels close enough to touch. The light is soft, neither morning nor night, shaped by a calm that seems to pulse like a heartbeat beneath the surface of the sand. You take a slow step forward. The ground shifts gently, accepting your presence without question. There is no hurry here. Even the wind moves in unbroken lines, flowing around you like a ribbon that never loses tension. Every motion feels deliberate, as if the world has simplified itself just for this moment. Far away, the shimmer of heat rises in smooth waves, bending the horizon. It feels less like an illusion and more like the desert breathing. You stand still and listen. At first there is nothing, but slowly a soft hum grows at the edge of your awareness. You realize it isn't a sound carried by air but something deeper, felt more than heard, an undercurrent running through the sand, through the sky, and through you. Each breath becomes slower. The desert doesn't ask you to calm down, it simply makes calmness unavoidable. The space is too open for worry to hold its shape. Thoughts loosen, then drift, then fall away entirely as if the sun has melted them into the ground. A line of dunes rises ahead, curved like waves that froze mid-motion. You walk toward them. Your footsteps leave prints in the sand, appearing sharp at first and then softening as the wind brushes over them. It feels like a promise: everything heavy can fade here, everything hurried can slow, everything tangled can untie. You climb the nearest dune. The slope is steady, the sand warm beneath your feet. Near the top, the horizon expands until it feels like standing on the edge of a quiet ocean. You pause there, letting the openness around you seep into every part of your awareness. The desert holds nothing back, yet it also asks for nothing in return. At the crest of the dune, you see a single flat stone resting alone on the sand. It looks out of place in a landscape shaped by wind. You sit beside it, feeling the stillness settle around you. The stone is smooth and cool, a perfect counterbalance to the warmth beneath your hands. A soft brightness fills the sky, not harsh, not dim, just clear. It makes every shadow gentle and every color simple. The air carries a faint warmth that wraps around you like a blanket. There is a silence here that doesn't feel empty. It feels full of space, full of breath, full of something steady and grounding that you didn't realize you were missing. The hum beneath everything grows more noticeable, yet it stays soft, steady, constant. It doesn't pull your attention, it simply offers itself, a reminder that even in stillness, something within the world is always moving with a kind of patient purpose. Sitting there, you notice the desert has no clocks. No walls. No boundaries. Just openness, expanding outward endlessly. It reminds you that time can stretch when it isn't crowded, and you feel yourself stretching with it, your thoughts loosening even further, your breath lengthening, your mind settling the way sand settles after wind passes by. You close your eyes. The sun glows against your skin, warm enough to soothe but not enough to distract. Behind your eyelids, the desert remains. You can almost picture the dunes breathing in quiet rhythm. Your breath aligns with that rhythm, slow and even, as if the land itself is guiding it. When you open your eyes again, the horizon seems wider. A faint trail of light runs across the sand, glimmering like a thread that leads nowhere in particular, but also everywhere. You follow it with your gaze, not needing it to promise anything. In the stillness of this place, you don't need direction. The experience is enough. A small whirl of sand rises nearby, swirling in a smooth circle before dissolving. It leaves no mark, no sign it ever existed. The moment is brief but complete. The desert teaches you something with that single motion. Even a passing moment can be whole. You lie back on the warm sand. It forms gently around you, creating a perfect cradle. Above you, the sky is vast, unbroken, and soft around the edges. The color deepens slowly, shifting just a little, as if the world is turning in the calmest way possible. The openness feels endless but never overwhelming. Instead, it feels like an open invitation. You breathe again, softer than before. The hum beneath the surface blends with the quiet inside you. For a moment, it becomes difficult to tell where the desert ends and you begin. The stillness you feel is not emptiness, it is spaciousness, a place where everything unnecessary has been allowed to fall away. A long stretch of time passes, though you can't say how long. Here, time doesn't divide itself into minutes or moments. It simply expands, filling the space between your breaths. You feel lighter, more grounded, as if you've been set down gently into a part of yourself that is rarely this quiet. Eventually, you sit up again. The sky has shifted slightly, but the calm remains unchanged. The desert waits, patient and vast. There is no pressure to move, no pull to leave, no urgency at all. Only the softness of the sand beneath you and the steady presence of the world around you. As you stand, your footprints mark the ground again. They are not perfect. They do not need to be. The wind will shape them soon, smoothing their edges, reminding you once more that everything transforms gently in its own time. You take one last look at the wide horizon, allowing the stillness to imprint itself in your mind. Then you begin to walk forward, carrying the quiet with you not as something fragile, but as something steady, something deep, something that will remain. The desert does not follow. It doesn't need to. The stillness it offered is already within you. The future arrives quietly, not with the noise of machines or the flash of discoveries, but with the soft unfolding of understanding. It comes the way dawn comes, slowly, gently, touching everything before you even realize the light has changed. And as you step into this final chapter of your journey, you feel that same slow shift, a soft brightening inside your awareness, as if the smallest pieces of the universe are beginning to lean closer to you. You walk through a space that feels neither past nor present nor quite tomorrow. It is a horizon made of possibility, wide and calm, shaped by the subtle glow of what quantum computing might become. The air is gentle here, carrying no urgency, no pressure to grasp everything at once. You move forward at the pace of your own breath, letting the thoughts settle softly. The future is not far away. It is already blooming beneath the surface of the world you know. Ahead of you, shapes begin to appear, not fixed or solid, but shimmering lightly, as though carved from potential itself. These shapes are the fields where quantum computing will touch human life, transforming the invisible foundations of medicine, climate, materials, and understanding. You approach them the way you might approach a quiet garden at sunrise, each step revealing more than the last. The first shape unfolds into a soft, pulsing light, the light of healing. You sense how quantum computers may someday help unravel the tangle of complex molecules, folding proteins with precision impossible today. You imagine medication tailored so perfectly to a person's body that treatment feels less like intervention and more like a whisper of restoration. The air around you seems to thrum with gentleness, with the possibility that sickness itself might one day be met with deeper clarity and compassion. You take another step, and the horizon shifts. A second shape rises, broad and cool like the surface of a still lake. This is the realm of materials, the metals, crystals, and superconductors that will reshape the way energy moves through the world. quantum simulations may help us craft matter that carries electricity without resistance, that bends light in new ways, that stores energy with the patience of stone. You picture cities lit by fewer resources, technologies humming with smooth efficiency, a quieter world where energy isn't wrestled from nature but guided like a soft river. As you breathe slowly, another form glows near the edge of your vision. It moves like a drifting cloud, light, shifting, full of both uncertainty and promise. This is climate science. You feel how quantum computers could map the atmosphere with new subtlety, tracing the invisible threads of weather and warming, helping humanity understand how to protect the fragile balance of the Earth. Solutions that once seemed distant might one day unfold like petals, guided by the exquisite precision of quantum computation. You walk deeper into this future landscape, and the air begins to shimmer again. This time, the shape that appears feels different, quieter, more intimate. It pulses with something warmer than technology, understanding. You realize that quantum computing is not just a machine, it is a way of seeing. A reminder that the universe is more fluid, more subtle, more interconnected than our classical minds once imagined. And as this understanding spreads, it changes not only what humans can calculate but how they think, how they imagine, how they relate to uncertainty. You stand still for a moment, letting that thought rest inside you. The future will not only reshape what humans can build, it will reshape what humans believe is possible. As you step forward again, the landscape widens. The horizon becomes a canvas of soft colors, blending into one another without edges. You sense countless futures flickering here, each weighted with probability, just like the qubits you've come to know. None of them fixed. None of them guaranteed. But all held gently within the realm of possibility. The world ahead does not feel rigid or predetermined. It feels open, flexible, shaped by the choices humanity will make as quantum tools grow in power. These tools will not arrive fully formed, they will require patience, creativity, responsibility. But already, you can feel how their presence will expand the boundaries of what life can become. A faint breeze passes by, carrying with it another scene, a quiet room glowing with pale blue light. You see researchers working with machines cooled to temperatures colder than space itself. Their hands move slowly, their breaths measured, their eyes focused not on the machinery but on the fragile qubits within. There is reverence in their movements. They know they are touching the edges of something profoundly delicate and profoundly powerful. You step closer to the scene. The researchers fade, replaced by another image, a quantum processor small enough to rest in the palm of a hand. It gleams softly, etched with patterns that look almost organic. The machine doesn't hum. It doesn't glow. It simply exists in quiet precision. You can almost feel the stillness inside it, the silence qubits need to survive, the sanctuary built for them so they can hold their fragile superpositions. As you watch it, you feel a tenderness rise within you. Technology is often imagined as loud, metallic, overwhelming. But quantum computing is different. It requires gentleness, calm, quiet, patience. To work with something so delicate is to learn a softer kind of engineering, one that echoes the way nature itself holds possibility. You take another breath. The scene fades. The horizon returns. In the distance, a final shape flickers, brighter than the others. You walk toward it slowly, feeling the sand or perhaps something even softer under your feet. As you approach, the shape dissolves into an open doorway. Its frame is made of faint light, barely visible, but wide enough for you to pass through. You realize this doorway does not lead to a specific future. It leads to all of them. You stand in front of it, feeling the quiet invitation it offers. The future is not something you arrive at. It is something you grow into, one gentle choice at a time, one insight at a time, one curiosity at a time. And quantum computing, for all its complexity, is ultimately a reminder of something simple: the universe holds more possibilities than we can see. More paths. More solutions. More ways of being. You step closer. The light shimmers softly around the edges of the doorway, flickering in a rhythm that feels familiar. It is the same rhythm you felt many chapters ago, the rhythm of qubits, of superposition, of entanglement. The rhythm of everything small and subtle that makes reality what it is. You reach out your hand. The light warm against your fingertips. You don't pass through, not yet. Instead, you pause at the threshold, breathing in the gentle openness of everything ahead. Behind you lies the journey you've taken through particles, waves, logic, fragility, resilience, possibility. Ahead lies whatever comes next. And as you stand there, surrounded by calm, one soft question rises inside you, carrying the hush of 1,000 quantum whispers.